Hi everyone, welcome to my YouTube channel, and I've created a C program that is supposed to find the roots of a quadratic equation in the form ax squared plus bx plus c is equal to 0, and then it is supposed to return values of the roots and also identify the type of the roots, whether they are real or complex. So let's dive into it. Here we have a, b, c, d, then root 1, root 2, plus the real part and imaginary part. These are the variable declarations used to store the coefficients. A, B, and C are coefficients. D is the discriminant, which is given by b squared minus 4ac. Then we have the roots, root 1 and root 2. Then for the complex roots, we'll have the real part and the imaginary part. So first here, we are going to print the student details. Then as we go on, D is the discriminant. So here we prompt the user to enter the coefficients of A, B, and C. Then here on the next part, we see exception handling, where the program is supposed to check if A is 0. In the case where A is 0, the program returns an error message and does not run. Yes. Then we go on to define the D, the discriminant, which is given by b squared minus 4ac. And then we continue. If D is positive, then it means D is greater than 0. Therefore, the equation has two real roots and distinct. By real and distinct, we mean that the roots are real, but they are different. For example, if you put in an equation and it gives you two roots, 2 and 3, they are real, but they are different. Then we continue in this part. If D is 0, then the equation has one real root or repeated root. So in this case, we have one real root, but it is equal. Let us say you have a root 2. So root 1 is equal to root 2, as you can see. That is what we mean by real and repeated. So we continue. If D is negative, meaning D is less than 0, then the roots are complex. And hence, complex roots are split into real parts and imaginary parts, and in the form of a plus bi and a minus bi. So here we print the complex roots, then we get the real part and the imaginary part, then we also print them. Then that's the end of our code. So let's run it and we see the results. When we run it for the first time, we are going to check out for the complex roots. Let us say my first coefficient is 1. Then the second one is also 1. Even the third one. It gives us complex roots. This is in the form, I said a plus bi, then a minus bi. So this negative one is my a, and then this positive one is my b. In the same case, that's it. Then we go on to test for the real but distinct. We run again. Our first coefficient is a 1. Then the next one is negative 4. And then the next one is 4. We run. Actually, this is real and equal to root 1 is equal to root 2. Then we check for the real and distinct. Coefficient A is 1. Coefficient B, let it be negative 5. Then coefficient C, let it be a 6. We run. Yeah, so these are real and distinct. We can see that we have printed the nature of the roots, and then we also printed the roots. So our aim was to get the roots of the quadratic equation and also determine whether they are real and distinct, real and equal or complex. So that is done. So let us try and check for the exception handling when we put our a as 0. Let us say our coefficient of a is 0. Enter. Then the next one, then the next one. It returns an error message saying that a cannot be 0. So that's it with my C program. In summary, the program takes coefficients of a quadratic equation from the user and calculates the discriminant to determine and print the real roots or complex roots. Thank you.